Hey everybody, this is Larry. This is me doing 12th day of August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. And today we're going to do Pascal's triangle 2. Given a non-negative index k, where k is less than 33, return the kth index row of the Pascal's triangle. Note that the row index starts from 0. Okay. So there are a couple of ways to do it. There are a couple of ways to do it. There are a couple of formulas for it. You could do it with dynamic programming. You can do it with, I guess, dynamic programming and factorials. It's essentially n choose r, and for k, it's just for k choose from k choose 0 to n or something, or k choose k or something like that, right? Yeah, so I think that's what I'm going to do. And in Python, there's a math.factorial thing. And I think I'm gonna use that. You can pre-cache the factorial so that you can use it later. But yeah, I think that's what I'm gonna do. So what's n choose r? N choose r is equal to n factorial over r factorial times n minus r factorial, right? So that means that, and in Python, it actually doesn't matter because you have infinite position, and 33 factorial is probably not super long, though. I mean, it's not super short either. But yeah, I think that's why I'm going to do it. But I think in another language, you may have to be careful, and you may rewrite this, for example, as something like, n times n minus 1 times n minus 2 dot 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 over, and it goes to actually to n minus r times dot 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 times n minus r, and then n minus r factorial or something like that, right? So that you can solve the r factorial with the thing that's oh, actually that's wrong, I guess. It's just n plus 1 or something like that, right? So that all the r factorial cancels out and so forth, right? But because I am using Python, I am going to be a little bit lazy, so that's what I'm just going to do it with the math.factorial way. I think it's also a combination library, but I should look that up at some point. But for now, I'm just going to keep it simple. So yeah, let's go. Results a range of row index. Maybe off by 1 here, but and that should be roughly at minus potentially off by 1, just because. And this is why would I say that is that um, with experience, you know that you're how close you are to being right, and sometimes you just have off by 1s, and that's okay. Just make sure you know what you're doing. Oh, whoops. I am off by 1. See? Oh yeah, because it doesn't include the row index, so that's okay. Yeah, this looks pretty okay, so I'm relatively confident. So let's just submit it. But yeah, but this is a very well studied problem. So there are a lot of different ways to do it. As usual, what I say about practice is practice the things that you want to get better at. And for me, like maybe I would do it again with dynamic programming because both top down or bottoms up, whichever one you have more trouble with, just to practice, right? Yeah. So of course, this is going to be only all of k space, and it depends on how you want to define the complexity of this calculation. I mean, you could also just cache it, to be honest, so that all of these will be all one, and then it'll be okay if you have any doubts. But yeah, that's all I have for this problem. Let me know what you think. Hit the like button, subscribe, and I'll see y'all tomorrow. Bye bye.